Welcome back. So today we're going to be looking at a ruler postulate and a segment addition postulate. So we're going to be using the handout that looks like this. This on the inside. So we are creating another foldable here, so we're actually just going to fold this in half, like so. And then you can cut along that dotted line there, so we're going to actually have two little doors here. So on the inside of this, we're going to go ahead and zoom in just a little bit here. So on the inside of this, we're going to start out with our ruler postulate. So the ruler postulate tells us that the distance between points A and B, written as AB, is the absolute value of the difference of those coordinates A and B. Okay, so what that means is the difference, we're going to be subtracting those values, and we want the absolute value. So we don't need positive or negative, we just want to know the distance there. So line segments that have the same length are called congruent segments, and that's going to be really important. So I am actually going to go ahead and highlight that, being congruent. And yes, if you like to highlight with different colors, that's absolutely fine. So then we have a practice problem here. It says we're going to use the diagram to find the length of AB. So we have point A is here, point B is over here. So what we're going to do in order to find that is we have segment AB. Remember we talked about to say a segment, we have no arrows on the ends, equals the absolute value, and then we have a value of 4 over here at B, so we're going to put 4 minus, difference means subtract, and then we want the value at A, and the value at A is a negative 2, so that's going to be a negative 2, and then we close in our absolute value symbol. So 4 is a negative 2. Well, if we minus a negative, that means that we're going to be adding these. So 4 plus 2 equals the absolute value of 6, which we know equals 6. Okay, so our final answer, the length of that segment is actually 6 units. Okay, so then we have a few more examples here of that. So we're going to use the diagram to determine whether segment AB and CD are congruent. And remember, we said congruent means that they are the same length. So we're going to find the length of AB first. So AB equals, so for AB, we're going to be looking at our x values again, since this is a horizontal line. So we have 6 and we have 1. So we want the absolute value of 6 minus 1, and then close in that absolute value. Well, 6 minus 1 is 5, so the absolute value of 5 equals 5 units. We're going to do the same thing for segment CD. So CD with our segment symbol. Now CD is going vertically, so our 2's are going to be the same, so we're looking at our y's this time. So we have a 3 and then 8. So I'm going to go 8 minus 3. I'm going to close in my absolute value symbol. 3 minus 8 is going to give me 5. And the absolute value of 5 is still 5. So then we know that A, B, and that's a segment, is congruent. So the symbol here means congruent to CD. So that congruency symbol, it looks like an equal sign with a little squiggle over the top of it. And that means congruent. Okay, so let's do another example here. We're going to use the diagram to determine whether AB and CD are congruent. So again, we're going to come over here to A. So AB equals, let's look here, we have a horizontal line, so we're looking at our x values here. Those are the ones that are different. So we're going to go absolute value of 2 minus, and the other one is a negative 3. So 2 minus a negative 3, we're going to add, so that gives us 5. So absolute value of 5 equals 5. Then for CD, we're going to come over here for CD. The x values are the same. Those are both 3, so we're going to use our y values. So for CD, we have the absolute value, and we have 5 minus 1. So 5 minus our 1 and our absolute value. So 5 minus 1 is 4, and that is an absolute value of 4 equals 4. So these are not congruent. You can either say the congruent symbol and then cross it out, or you can say not congruent. Either one of those would be acceptable. Okay, so let's keep moving here. The other piece that we have is our segment addition postulate. So that tells us if B is between A and C, so these are points. So if point B is between point A and point C, then if we add together, so if we look here, if we add together those two segment pieces, we should get the entire segment. Okay, so let's take a look here at our practice problem. It says to find BC. So that tells us if I add together AB plus BC, I should get AC, which is the whole thing. So we're going to say AB plus BC equals AC, and those are all segments. Well, I know AB is 18, so I'm going to substitute 18 in for that. I don't know C, so I'm going to leave BC in there. Equals AC, and it tells me AC is 30. So 18 plus what gives me 30? I can subtract 18 from both sides, and I end up with BC equals 12. BC equals 12 units there. Okay? Alright, so let's try some examples over here on the other side. So we're going to use the diagram to find BC. BC is here. Okay, that's what we want to find. So again, we know that we have our AC is 32, the whole thing is 32, equals AB, which was 4x, plus BC, which is 12x. Okay, so I'm going to combine my like terms, so I get 32 equals 16x. So now what do I do? From here I'm going to divide both sides by 16, and I end up with 2 equals x. Well, I still need to find BC, so I'm going to plug that back in here. So BC equals 12x. So that's 12 times 2, which is 24. So BC equals 24 units here. Okay, let's try another one of those. So example 4, we're going to use this diagram again to find BC. So this time it tells us AC is 4x plus 4 equals my AB, which is 14, plus my BC, which is 3x minus 4. Okay, so I'm going to combine some like terms. Again, I have 14 and a minus 4, so I'm going to say 4x plus 4 equals 10 plus 3x. So now from here, I'm going to continue to simplify so I can solve for x. So I'm going to subtract my 3x from both sides, subtract my 4 from both sides. So now over here, those cross out. I'm left with 6 equals, on the left-hand side, my 4's cross out. I'm left with 1x, so x equals 6. But I still have to plug that back in because I want BC. So we said BC equals 3x minus 4. So that's 3 times 6 minus the 4. 3 times 6, I'm going to get 18 minus 4, which is 14. So BC, segment BC equals 14 units long. Okay? Alright, so for this foldable, you're actually going to glue this into your notebook on page 11. That's going to get glued into your notebook on page 11. Okay? Alright, so then the next piece that we have, this is a little bit different. So this is what we call doodle notes. So you'll see these throughout the year. You'll see some doodle notes. So this, feel free to color these in and doodle on them however you feel necessary. Like I said, these are doodle notes, so you can doodle on them however you'd like. However, I do have some pieces for you to fill in. So if you notice on this, we've got this first section over here. that says segment addition. So I'm going to turn that to the side so we can see that a little bit better. Segment addition postulate. Now we talked about the segment addition postulate just a little bit in that last foldable, so we're going to see how much we remember. It says if B lies between A and C on a segment AC, then AB plus BC equals, what would go there? Well, that's AC. Okay? The next thing it says is that we're going to draw a diagram showing this postulate. So we're going to draw a picture that demonstrates this. So I've got my segment A, C, and it says B is between A and C, so I'm just going to put it in between here somewhere. So let's put B there. So now if I look at this, I'm going to label this one X, I'm going to label this one Y. So AC equals X plus Y. So if I add together these two pieces, that gives me the length of the entire thing. Okay? Alright, so then let's go to this middle section. This middle section here, so it says we're going to be framing a wall. So it says each stud is 1.5 inches thick. The top and sole plates are also 1.5 inches thick. The space between two studs, so between two boards here, we have two boards in our wall, is 14.5 inches. The total height from the bottom of the sole plate to the top of the top plate is 99 inches. Okay, so we're going to be finding some different information here. We're going to find the height of a stud, and then we're going to find the length of the sole plate. So if you look on our picture, this down here, this is our sole plate. Okay, so we want to find the length of that. We want to find the height of our stud here. So we're going to look up here at this information again. Well, it told us the total height from the bottom, the very bottom to the very top is 99 inches. I apologize for that. It's 99 inches. So if I figure out what just the height of this stud is, we're going to have to cut off this top plate and the sole plate down here at the bottom. And if you remember, it told us they're 1.5 inches thick, each one of those. Okay? So I'm going to take my 99 minus, I have a 1.5 and a 1.5, so that equals a total of 3, right? 1.5 plus 1.5, we get 3, equals, and so what do we get there when we subtract off that 3? We should get 96 inches. If you wanted to convert that to feet, that would be 8 feet. Okay? Alright, so again, all I did was I took the total height and I subtracted this top plate, the top piece that was 1.5 inches, and this bottom piece that's also 1.5 inches, which gives me a total of 3 inches. I subtracted that from my total. Alright, so then the other one says find the length of this sole plate. So what does it tell us about that? So it tells us we know that each one of these boards, we said these were each 1.5, right? So 1.5, we've got 1.5, and another 1.5. It told us the distance between each of these was 14.5. So this is 14.5, 14.5, 14.5. So in order to figure out that entire length, I'm going to add all of those pieces together. All of those little segments need to get added together. So I have 14.5 plus 14.5 plus 14.5. That's all my spaces, right? 3 of them. And then I have 1, 2, 3, 4 boards. So 1.5 plus 5 plus 1.5 plus 1.5. Okay, so my boards, this is going to be 3, and another 3 gives me 6. For the spaces, I've got 14, plus another 14 would be 28, plus another 14, 28, 42, we've got a half, so that'd be 43.5. So we're going to take that 43.5 plus our 6 equals 49.5. And that's inches. I'm going to put my label of inches on there. Okay? Alright, so let's keep going here. So we've got to try it right over here. We're going to complete each equation using the points along the sole plate. We're going to write 2 additional equations of your own using the same points. We're going to find the segment lengths using the diagram to find each segment length or complete each statement. So you're going to complete this column, this last column on your own, and bring that completed to class tomorrow. This will get glued into your notebook on page 12. This goes on page 12. Okay? Alright, that is all for this video. I know it ran over 15 minutes. I apologize for that. I'll make it up to you in another video. Have a great evening. See you in class tomorrow.